Welcome to this webinar by the Design Lights Consortium, or DLC, introducing our new technical requirements for light usage for night applications, or LUNA. My name is Levin Nuck, and I will be your host. The purpose of today's webinar is to introduce the first draft of the DLC LUNA technical requirements, and to show you how to submit comments to the DLC in case you would like to see any changes in these requirements. We'll start with brief introductions of our speakers, followed by a few guidelines for webinar logistics. After that comes an overview of the LUNA program, and then a detailed look at the draft technical requirements. We'll end with questions and answers. Our speakers today all work at the DLC. Tina Halfpenny, our Executive Director, will introduce the new LUNA program. My name is Levin Nuck. I lead development of the DLC Network Lighting Controls program, and I'll describe the requirements for controllability. Leora Radetsky, the DLC's Senior Lighting Scientist, will describe the requirements for light distribution. Casey Holland, who deals with lots of questions about spectrum in his role leading the DLC's horticultural program, will describe the requirements for spectral quality. And Axel Pearson, who leads development of the DLC Solid State Lighting program, will be tracking your online questions. We will leave some time after the presentation to answer questions that you may have entered in the questions pane of GoToWebinar. We will answer some questions live as we go in this window during the presentation. We'll leave some time at the end to answer some questions aloud. For any questions that we don't have time to answer in the webinar, we'll follow up afterwards with each person who submitted a question. Because we have a large audience today, all attendees are muted. If you have any technical difficulties, please use the chat window to let us know. The slides that you see today, plus a recording of this webinar, will both be posted within a few days on the designlights.org website under News and Events. The LUNA Technical Requirements draft document that we will describe today can be found at designlights.org under Current Efforts by scrolling down a ways and choosing the Draft 1 LUNA Technical Requirements V1 button. The comment forms can be found at the same location by clicking the comment form button that is just below the Draft Technical Requirements button. To submit any comments about the LUNA technical requirements, please download the comment form as an Excel spreadsheet, save a copy with your name and with all of your comments, and then email it to comments@designlights.org by Friday, May 21st. That concludes my introduction about logistics. And now Tina Halfpenny will introduce the DLC and the LUNA program.
Thanks, Levin. Hi, everyone. I'm Tina Halfpenny. I'm the Executive Director of the Design Lights Consortium. I just wanted to give a little bit of a introduction to us as an organization. Our mission, we are a nonprofit organization. Our mission is to achieve energy optimization by enabling quality controllability with a focus on quality, people, and the environment. Our innovation guideposts are here as well. Energy quality and controllability is something that we strive for in all of our work efforts. I don't think I have control. Okay. There. Thanks. Am I the driver now?
No, I'll move the slides.
Okay. Our organization is made up of 24 staff. We have over 1,800 lighting manufacturers listed on our SSL, NLC, and horticultural lighting QPLs. And we have 75 energy efficiency programs who we call our members. So to talk to you a little bit about our LUNA program goals. Number one, minimize energy use, lighting energy use. We are using our baseline efficacy thresholds in our 5.1 requirements combined with dimming and control requirements so that we can ensure lighting efficiency with this LUNA program. that will help not only our members to meet their savings goals that they're looking for, but all of the other benefits that come with energy efficient lighting. And ultimately what we're trying to do is use light where it's needed. We keep saying wasted light is wasted energy. Second goal is to minimize light pollution. We know that this is a growing issue, a rapidly growing issue for, you know, basically the globe at this point. So the new LUNA requirements work to decrease the light scattered in the atmosphere that produces the sky glow and the light trespass that we see, and ultimately help to create darker skies and better illumination again where it's needed. And then the third goal is to provide appropriate visibility for people. So we've been lucky enough to experience lighting outdoors. We have been able to extend our day outdoors. We've been able to work more of our community activities outdoors thanks to lighting. We want to make sure that safety remains a key factor in our outdoor lighting at night. So again, we have based this on our 5.1 requirements: spectral quality, reporting of bug rating, spectral power distribution, intensity distribution, all of these things. Looks like we blew by the goals, but we're not done yet. All of these things help to allow specifiers and lighting decision makers to choose what is the right light for the application that the project that they're working on. I think now we can move ahead. Thanks. So the other question that I've been asked is why now? And I found this quote from the National Park Service. Researchers predict that at the current rate of increasing light pollution, by 2025, no dark skies will remain in the continental United States. The two main culprits are light and air pollution. So there is some urgency to this. Not only do we have the climate to be concerned about, where, you know, I think everyone on this call has been involved in the transition to LED lighting, which is making tremendous strides in energy savings. But you know, now we're sort of up against light pollution. Light pollution affects everything. Nighttime is essential to the Earth's ecosystem. I think we all know that inherently. I'm not sure how many of us actually think about it that way. But artificial lighting disrupts the rhythm of the day. It disrupts the rhythm of the night. We depend on this. Plants and animals depend on this. Our health depends on a solid night's sleep. I sort of wonder how many of us have blackout shades so that you can get a more restful sleep. I do. And, you know, for centuries, the stars have played a significant role in our lives, from, you know, the things that we believe to explorations to our own navigation, even our own imaginations about what exists beyond the planet. So to think that future generations, you know, in as quick as the next 5 years won't be able to sort of stargaze and wonder what exists beyond this beautiful planet of ours, you know, that's a sad thought. The reason why we're optimistic about light pollution is, unlike air pollution or water pollution, light pollution can be mitigated pretty immediately. When the light goes out, the light pollution goes away. So ultimately, we're looking at controls and controllability for all of this. I think that there's a solution once we get to a point where all of our lights are controlled. But this is a problem that we can solve together. Next slide. So why us? Why the DLC? We are taking this on as a matter of stewardship. With the largest lighting products list in the world, our specs are reviewed and referenced around the globe. We have enough information now to set thresholds and requirements that not only save energy, but also minimize the negative impacts of light at night. And with you, thanks to the community that we work with, think we can all make a pretty significant difference in this challenge. So this just gives you an idea of currently what we have on our QPL under the outdoor lighting categories. It's a very robust list, and I think that there is a lot that we can do with it to address this challenge. I think I have one more slide. Yes, I wanted to leave you with these images before we start talking about the technical requirements of Luna. One is images that we got from IDA, the International Dark Sky Association. This was during a blackout in 2003, 55 million people, buildings were out of power. So this just gives you an idea of how quickly the night sky can come back, but also how impressive that night sky is behind the sky glow that, too often we see. And then on the right is a NOAA image, satellite image. This is from 2016. I should have put that in here. So likely this image is probably brighter, but just, it's sort of at a aggregated scale what the image on the left looks like globally. So with that, I'm going to hand things back to Levin, and we'll talk a little bit more about Luna and what's involved in it. Thanks.
Thanks, Tina. So let's see if I can manage the slides. There we go. We released the first draft of the technical requirements earlier in April, based on guidance from our advisory group. We are now in the first public comment period that will end on May 21st. Based on the comments that we receive in comment forms, the draft will be revised and a second draft will be published in July. After a second comment period and revision, the final document will be released in October, and this is following the typical development of documents that our regular procedure that DLC goes through. The technical requirements are organized as shown here. To attain DLC Luna qualification, products must meet the solid-state lighting version 5.1 technical requirements, and then meet some additional new requirements for Luna, based on currently available standards and consensus-based metrics. Luna includes a few allowances that we'll describe later, so that a shielded product with relatively low efficacy might qualify for Luna because of the Efficacy Allowance. Here's a way to think about that in a Venn diagram. Of all the outdoor luminaires qualified as DLC solid-state lighting version 5.1, some of them will be eligible for Luna qualification. Also, Luna allowances will enable some shielded products to qualify for Luna, even though they need an allowance in order to meet the version 5.1 requirements for efficacy. The Luna document includes a one-page summary of the solid-state lighting 5.1 requirements, with highlighting of all the parts where Luna imposes different requirements than 5.1. As you can see in this highlighted chart, the main modifications are in distribution, spectral quality, and controllability. Briefly, distribution for Luna sets thresholds for the Uplight rating. For spectral quality for Luna sets 3000 Kelvin as the maximum CCT, and controllability for Luna requires continuous dimming down to 20% of maximum power. We'll address each of these topics next in more detail. The new allowances for minimum efficacy are covered in the distribution topic. This table shows the primary use designation luminaires that will be eligible for Luna qualification, such as pole-mounted area and roadway, wall mounts, parking garage, etc. This list does not include sports lighting or aimable spot and floodlights. And now Leora Radetsky will give us some more details about distribution.
Thank you, Levin. Hi, everyone. I'm going to spend the next few minutes, one slide up, please. I'll say next slide. Thanks. I'm going to spend the next few minutes talking about our proposed distribution testing and reporting requirements and allowances. Next slide, please. Thank you, Levin. In the Luna technical requirements, we are proposing to control the distribution of light in order to mitigate light sky glow and light trespass. The uplight component of the distribution is often unused, resulting in wasted energy and increased sky glow. To limit uplight emitted directly from the luminaire, we are proposing to set thresholds on the uplight or U component of the bug rating. AIM luminaires can also increase sky glow and light trespass, so we are proposing to not allow aimable PUDs, such as floodlight and spotlights, to be eligible for Luna version 1. Finally, we know that shields may improve the quality of the light distribution, so we are proposing efficacy allowances to encourage more shielded products to be listed. Next slide, please. Let's get into the technical testing and reporting requirements with regards to distribution. The first requirement for Luna eligible luminaires is a threshold requirement for the U rating. Depending on the PUD, as shown in the second table, the maximum allowable U rating is either a 1 or a 2. Obviously, lower U ratings are allowed. Generally speaking, pole and arm mounted luminaires, as well as bollards and full cutoff wall packs, have a maximum U rating of 1. Decorative luminaires, as well as canopy lighting, parking garage lighting, and other wall packs have a maximum U rating of 2. The bug ratings, as in version 5.1, will be shown for parents and child products. And new to Luna, we are proposing to show an image of the luminous intensity distribution for parents and single products. We are proposing to ask for reported data in TM33 XML document format with a provisional pathway for IES files. Next slide, please. As previously mentioned, aimable products are not eligible for Luna version 1. However, to allow pole and arm mounted products to be installed such that the optics are parallel to the pavement, we are allowing mounting options such as fixed mounting that do not allow a tilt angle of more than plus or minus 5 degrees. Luna qualified products will include a model number that specifies the conforming mounting option. If a family of outdoor products includes multiple mounting options, some of which are eligible for Luna and some of which are not, only the subgroup of mounting options which does not allow a tilt angle of greater than 5 degrees would be eligible for Luna. The remaining family members would be listed under version 5.1 only. Next slide, please. Luminaires with auxiliary shielding may improve the quality of the light distribution as light is only delivered where it is needed, rather than potentially causing light trespass on neighboring locations. Shields may also be used to address glare complaints, proactively or retroactively. Luna qualified products must offer at least one shielding option on their specification sheet. This may be one or more house side shields, cul-de-sac shield, a front side shield, or a glare shield. There aren't many shielded outdoor products currently on our SSL QPL. This is likely because shielded products typically have lower efficacy values because the shield reduces the luminaire efficiency. To encourage shielded products to be listed on the QPL, DLC is offering efficacy allowances for Luna qualified products if the zonal lumens are reduced in the solid angle of concern, either the backlight angle for house side shields or cul-de-sac shields, or the front light angle depending for front side shields. If a manufacturer offers more than one configuration of a specific shield type, like a house side shield or cul-de-sac shield, the variety of configurations under each shield type is treated as a shield type subgroup, and the product with the lowest efficacy is listed as the worst case efficacy parent. Next slide. This table shows the proposed efficacy allowances for each shield subgroup for specific types of Luna qualified PUDs. There is a minimum reduction in either house side or street side lumens that is specific to the shield subgroup. For example, a house side shield reduces the house side lumens by a certain amount depending on the shield properties. The image at the top shows a hypothetical luminaire without a shield on the left and with a shield on the right. The proposed house side shield efficacy allowance stipulates that a luminaire with a house side shield has to reduce the house side lumens by at least 50% compared to an unshielded product with the same absolute distribution to get an efficacy allowance of 20%. Other efficacy allowances for other shield types will require different reductions in house side or street side lumens, as noted in this table. These allowances are in addition to other cumulative spectral quality allowances provided in version 5.1. The maximum allowance for a shielded Luna qualified product is not limited to the maximum allowance of 15%, as in 5.1. Instead, for Luna, it may be up to 50%, depending on the shield subgroup. Next slide. Finally, in the first draft, we shared 6 key questions on distribution we would like to get your input on. I don't have time to go over these in the webinar, but we would like to remind you to please share your comments to these key questions, as well as any other comments you have, using the Luna comment form. Thanks for your time and attention. We look forward to your comments and questions. Next up, it's Casey Holland.
All right, thank you, Leora, and thanks for moving the slide along Form 11. We can go ahead and hop into the next slide. All right, so just as a reminder, the level set of what you've already heard from our other speakers, the spectral quality rationale for Luna Draft 1 proposal is really aimed at kind of mitigating sky glow caused by LED or outdoor LED lighting at night. In particular, it's to minimize light pollution and energy use while maintaining appropriate visibility for people. And we are operating off of the version 5.1 technical requirements as a baseline. So the things I will be proposing specifically for Luna Draft 1 will be either clarifications or additions to the version 5.1 technical requirements, specifically spectral quality. All right, next slide, please. Okay. So right at the top, proposal trying to mitigate sky glow, as Tina mentioned earlier, and which is often associated with a kind of Rayleigh scatter or an interaction with the light and smaller particles that cause scatter of that light into its atmosphere. And if you can see it in daylight, it's kind of what gives the sky its blue color from sunlight going through this Rayleigh scatter interaction. There are a lot of research out there that tries to work toward addressing these kind of things or characterizing these things. Department of Energy has released some research that found CCT to be a poor predictor of sky glow because CCT is not wavelength dependent, whereas sky glow is because it's significantly related to Rayleigh scatter. And just like sunlight gives sky blue color, LEDs are more susceptible to Rayleigh scatter and lower wavelengths. So it's difficult to try to kind of characterize sky glow simply by looking at CCT, but that is what industry best practices currently recommend because of a lack of industry adopted standardized metrics in this space. As you can see on the right hand side of the screen is the U prime V prime color space from ANSI 78377 2017, which characterized white lighting in a range from 2200K all the way up to 6500K. This is the full range that we allow in version 5.1 for outdoor lighting. But industry standards, in order to kind of minimize sky glow and light pollution, propose limiting in commercial zones your CCTs to 300 or 3000 Kelvin or lower. And in more sensitive environments, recommend limiting your CCTs to 2200K or lower. As you can see, 2200K is the very lowest CCT that is standardized by ANSI 78. And outside of this 2200K to 6500K range is considered non-white lighting, except for the extended and flexible CCTs that are kind of in between this. But to the right of 2200K or less than 2200K is considered non-white lighting. And as far as we are aware, there are not standards in place for characterizing product performance in that range. So if you can move to the next slide, Form 11. As Levin already mentioned earlier, we're proposing to limit in Luna version 1, draft 1, the chromaticity range from 2200K to 3000K because we rely on industry standards for proposals here at the DLC, and we are just simply not aware of standards. And if you are, we have some key questions on that. I would love to hear from you, so please reach out and we can have a conversation. But for now, draft 1 proposes 2200K to 3000K as eligible chromaticity ranges for Luna specifically. That doesn't mean that your version 5.1 family can't have products outside of this range. It just means that if they are outside of that range, they would not be Luna eligible. And just like Leora described for distribution, that group of CCTs or variations within that family that are offered within this eligible range would be Luna eligible and considered a spectral subgroup of that family, specifically for Luna. And we're proposing to collect the spectral data per TM33 with a provisional pathway for TM27 or SPDX files, and to show an image of the SPD on our QPL. If you're familiar with our horticultural program, this is something that we're doing over there. If you're not, go check it out. That's a plug for me. I'm the horticulture program manager also, so let me know if you have any thoughts over there. Anyway, back to Luna. Another thing to consider, if you have spectrally tunable products, either white tunable or warm dimming, and you're considering them for Luna or you're interested in it, we are proposing here in draft 1 that those would be eligible for Luna so long as they only tune between the proposed eligible chromaticity range of 2200 to 3000K. Additionally, the 5% efficacy allowance for products with CCT 2700K or lower is still in place for Luna products. All right, next slide, Levin. So building on, as Leora and I both mentioned, the TM33 and LM79 requirements for reporting this spectral and spatial distribution information, we are proposing some additional reporting guidelines specifically to LM79 and TM33. They're a little bit further back in the technical requirements draft that's been released. And there is some information about grace periods for transitioning to the newer versions of these testing standards and reports and data transfer files like TM33 or TM27 and LM63. So make sure you're reading that section also and giving us some comments on that if you have them. So there is that provisional pathway where you can use TM27 and LM63 information instead of TM33 right away and the older LM79 format, where you would have to update by the end of a grace period, which is still TBD. And next slide, Levin. So just like with distribution, we've got some key questions for spectral quality related to non-white or potentially amber or other kind of non-white sources, and ineligible chromaticity ranges, and these kind of metrics for kind of better characterizing sky glow or addressing potential limitations that we know for CCT for considering spectral quality impact in light at night. So with that, thank you, and I look forward to reading your comments. I'll hand it back over to Levin.
Thanks, Casey. So next we'll talk about controllability. If I can figure out, sorry about this, every time I turn my video on and off, I lose control of the slides. There we are. For Luna, we propose to get more specific about luminaire capabilities for dimming and controls. The main goal is to minimize sky glow and light trespass flexibly throughout the night by dimming down as far as feasible, as frequently as feasible. A second goal is to save some electricity by dimming. And third, we want to recognize cost-effective ways to accomplish the first two goals, that might not have comprehensive network capabilities such as individual addressability or remote diagnostics. To meet those goals, we propose that all luminaires should document their capability for control with 2 new requirements in the first 2 rows and 2 additional reported fields in the bottom 2 rows. All luminaires must be capable of continuous dimming down to 20% of full output power. In terms of how they're controlled, the solid-state lighting list already provides some information about controllability. We plan to add some additional questions to gather more detailed data to help people know more precisely how a luminaire can be controlled. Excuse me. While Luna includes some hazardous primary use designation, these are exempted from controllability requirements since dimming is usually not desirable or available in a hazardous application. The product specification sheet and the SKU are required to identify a standard dimming protocol. If a single driver can accept both analog and digital inputs, then the analog and digital standards can both be identified. For reporting on integral controls, version 5.1 already includes the following options for sensors and for capabilities, as shown on the right in these excerpts from the SSL v5.1 technical requirements. We've added some additional aspects of integral controls outlined in Luna Table 8, such as part night dim and photo control with self-calibrating astronomic time clock. Also, we added a longer list of control receptacles. The product specification sheet shall clearly identify available integral control sensors and capabilities, along with the ordering code for each option. In order to support the selection of luminaires and network control systems that are likely to work together, the product specification sheet shall clearly identify available communication standards selected from this list in Table 9, along with the ordering code option for each standard. And that concludes the section on controllability. Here are a few key questions that are in the technical requirement. And again, in the interest of time, I will not go through them in detail, but I encourage you to download the comment form and address the key questions from each section, along with any other comments that you would like to add, and then email that completed Excel spreadsheet to comments@designlights.org. And so now we have some time to see questions that have arisen during the session, and I think, can I turn it over to, well, I'm not sure who comes next on this, Axel, or I think I'm asking Axel what we're doing next.
Sure, Levin, I will go ahead and read some questions aloud for our panelists.
Thanks.
And I've got a set up here, so let's start with the first one. I'm going to say, well, either Casey or Leora, is TM33 being used by any other programs, and what readers and lab software are available?
Okay, I'll take this one. Casey, jump in if you want to add something. So at the moment, we don't know of commercial photometric software that will read TM33 files. You know, it is an XML file, so we're easily able to open them, for example, in Excel, and that's exactly what we do with SPDX files, actually, which are a similar format. One of the reasons why we have a provisional pathway that allows, for example, IES reporting or SPDX reporting, as well as a grace period, is to allow time for a commercial software to include this capability. And we're hopeful that this happens sooner rather than later.
Great.
Yep, sorry.
Thank you. That sounds good to me. Okay. Leora, I'm going to give you another one on bug. Uplight in bug ratings for bollards often contains a large reflected component from the light body or structure. You mentioned that Uplight is direct Uplight. how do you propose manufacturers measure only direct uplight as opposed to indirect reflected uplight in bug rating scan?
Well, that's a very good question. So let me just clarify. By direct uplight, we mean light that is emitting from the luminaire directly, not that is emitting from the ground or, for example, from a building, like you would have in a wall pack. So we mean directly from the luminaire structure. So any performance affecting structure, like, for example, a yoke in a decorative luminaire, or other performance affecting structure that changes the distribution must be included in the gonio-photometric testing, in other photometric testing, and that's been part of our technical requirements for a while. It certainly is a part of it for Luna.
Great, thank you. Leora, I'm gonna give you a little break, but I've got more for you. I'm gonna hand one to Casey. Casey, this is about color tunable products. Is a product that tunes between 3,000, 4,000, and 5,000 K eligible for Luna?
Oh, so good question. As proposed in draft 1, we would not say that this product would be eligible because it can tune to outside of the Luna eligible chromaticity range.
Okay, great. But that is to say, what if a product can tune between 2,000 and 3,000 K?
Again, so since 2000K is just on the lower end, outside of our 2200K minimum range, that would also be ineligible as proposed in draft 1.
Okay, I meant to make you answer yes, so maybe I should say 2200 to 3000K would be eligible. Thank you, Casey.
That would be perfect.
Okay, another one coming at you, Casey. Is LM7919 required, or will LM7908 data, the kind of older version, still be acceptable for Luna?
So as proposed in draft 1, again, we are proposing a provisional pathway where we will accept LM7908 testing and have a certain grace period, which will be sufficient, and communicated well in advance to make sure that if any testing does need to be done in order to update from LM7908 to LM7919, that would be done. But yes, there is a proposal in draft 1 that we would eventually require LM7919 files.
Okay.
Reports.
Great. I'm going to take one to give our panelists a little bit of a break. Question is, generally, is the DLC going to make all outdoor products meet the Luna requirements? Or another question also came in that, will there still be normal outdoor listed luminaires? And the answer is yes, there still will be other DLC qualified outdoor products that are not Luna qualified. Luna is a subset of the SSL QPL. And so those products that want to meet the extra light pollution mitigating requirements will be eligible for Luna. And those products that do not want to go for the Luna qualifications can still remain DLC qualified. Okay, Leora, another one coming at you. The requirement for shield options to allow a lower efficacy products into Luna, would it exclude products specifically designed, sorry, let me start over. The requirement for shield options to allow lower efficacy products into Luna would exclude products specifically designed to have no backlight. Could a product with an optic specifically designed to provide precise pathway lighting with no backlight or uplight be allowed into Luna?
Okay, that's a great question. So we are proposing in draft 1 that in order to get the efficacy allowance, you would have to use it through a shield subgroup, which would be an optional shield above and beyond or in addition to any optics that the manufacturer already provides. And we know that there are optics that manufacturers provide that can cut out a significant portion of the backlight component, for example. We heard through our development process that it really was desirable to have an additional shield, an optional shield to mitigate concerns and complaints that happen in the field, because you can't perfectly optimize a distribution. Now, that is something that we'd like to get some more comment on. So if you have examples, for example, specific photometric examples where an optic cuts off 100% of the backlight, or and has an efficacy sort of hit, if you will, as a result, then please communicate that with us through the comment form, reach out to us, and we want to understand that better. But specifically, we heard during the development process that an additional shield is really necessary to address concerns and complaints that happen in the field.
Okay, thank you. Another TM33 question for Leora or Casey. How is TM33 an improvement over LM79 in general?
I'll take that one, Casey, and then if you want to add on, that would be great. So TM33 I think has a number of improvements over our current files. First and foremost, it combines the spectral and spatial information together, so that rather than, for example, only having luminous intensity values and using V lambda, for example, as the weighting function, by having the spectrum and the intensity distribution together, or radiometric distribution together, we can scale the information to address other metrics that may be of interest in the future. So I think that that coupling is really, really important, so that we eventually get out of the forever lumen sort of metrics that we have. The second reason I think that TM33 is better than IES files, for example, is that you can have more than one luminous emitter for the luminaire. So we know that there are luminaires that have multiple luminous emitters. This affects our perception of their discomfort glare, of their brightness. And so by having more data about the luminaire, I think it just makes our predictions and our photometric analyses much better. Casey, do you want to add to that?
Yeah, I'll add just a little bit. So as everyone knows, we process a lot of applications here at the DLC. So trying to get data, in standardized formats like TM33 rather than an LM79, which can kind of have any format in the test report coming from all different kinds of test labs, really helps us with our process also. It can help, improve our application process in general.
Great, thank you. Good answers. Okay. Levin, you haven't gotten a question yet, so I'm gonna give this one to you, but I think it's open to the whole DLC team. So why should the average lighting salesperson or end user be concerned with Luna?
Well, thanks for including me, and I will take a start, and then everyone else is welcome to chime in. But I would say the first reason is that DLC has heard in the past that many outdoor lighting projects that are in commercial spaces but near residential neighborhoods have difficulty finding shielded products that qualify for DLC, and so many efficiency programs have difficulty with say making an exception to incent the shielded product, or buying luminaire first and adding a shield later or something. So Luna will provide a straightforward pathway to include shielded products, which we have heard that many sales reps and efficiency programs both want to include in the incentive programs, but until now have not been able to. I guess I will say one more. To the extent that anyone just enjoys looking at the night sky, keeping tabs on astronomical discoveries, enjoying the dark. You know, think of the reasons that you might enjoy going out camping or walking in the woods. And for me, one of the main reasons that I like it is getting to see the stars at night when I'm far from a city. And this because LEDs are so controllable and the distribution can be very distribution, the spectrum, the timing, everything can be specified. We have the opportunity to not only to completely reverse the process where we've been losing ground. We've got LEDs now and we're losing ground faster. We could be actually getting darker and darker skies for precisely because of the good qualities of LEDs, that we can control the spectrum, we can control the distribution, and we can control the dimming capability. So anyone else want to add to that?
I think that was a pretty good answer, but I'll still let the other team members jump in if you want. Otherwise, I will queue up the next question. Okay, I'll take that to move on. I'm going to take one. Casey already answered the question about the grace period allowed to accept both LM7919 and LM7908. There's a question on if there's a timeline for that grace period, and the answer is not quite yet. More information on the implementation and application process, including fees, will be released with draft 2. So draft 1 is focused just on the technical requirements at this point. So again, more information on implementation will be included in the next draft, so stay tuned. Leora, I've got another one for you. I think it's similar to one that you already answered, but a little bit different. So I'm going to go ahead and read it again, or read this one as well. It's on shielding. You mentioned that shields can reduce efficacy, and therefore we're creating allowances. Aggressive optics to reduce backlight and shape the light to output the increased usable light. It has the same effect on reducing efficacy. Does the efficacy allowance also apply to the optics that reduce backlight similar to shielding?
Thanks, Axel. I think that one is similar to the other question. So again, right now our proposed efficacy allowance is only to additional shields that can be added on top of any other optic, whether it's an aggressive optic, for example, or something else. And that's because we heard during our development process that an additional shield is really important to address complaints in the field, because you can't do that with a standard optic, that there's always going to be a complaint, and it's good to be able to address that. But again, we want to hear from you. So if you will reach out to these people that had questions, if you can give us examples of optics that aggressively shape the beam, as you're saying, and do essentially the same thing as a shield would do with regards to our allowance requirements for reducing the backlight or front light. We'd like to talk about that and see that information and see if we missed anything. So we appreciate the feedback.
Okay, thank you.
Thank you. Thanks for the question.
Okay, we are approaching just about 10 minutes left, and we have some wrap-up slides. So I think we answered a good amount of questions. If you did not get your question answered, I assure you that we will download the questions from GoToWebinar and follow up with you for those of you that still have outstanding questions. But I'm going to hand it back over to Levin to bring us home.
Thanks, Axel. Well, I think we just have this final slide saying thank you for attending this webinar, and thank you for all of you who will take the time to look through the technical requirements and fill out the comment form and send them in by Friday, May 21st. Then we will collate those comments and look at ways to address them, and then publish the next draft in July. So once again, thank you very much for attending, and this concludes the webinar.